Hi everyone, I'm Sungkyun Im from School of Chemical Engineering in SKKU. Our lab specializes in modeling and simulation using multiscale and multiphysics. And one of the topics that I want to talk today is physical uncontrollable functions. That could be unfamiliar in the field of chemical engineering. The number of personal devices is increasing with the rise of IoT, and it is becoming more important to protect personal information. However, attackers are becoming more skilled at tampering this information. Traditional software-based security systems may not be enough to prevent these attacks. So PUF has arisen as a solution. A PUF is a type of physical security material. It generates output based on its unique physical properties, not through the programming. For example, imagine a scenario where a user wants to transfer money from their bank account. In the past, we would need to use a security card, in other words, ID password system. But if attacker were tamper the pre-generated ID password pair, the authentication system would be invaded. In the PUF case, the user has a function that can create infinite number of unique ID password pair. That means even if an attacker are tampering their some pair, the user and bank can still use different generated pairs. We will call this system a challenge and response instead of ID password from now on. The bank also has an inverse function that can transform from the response to challenge. In PUF research, it is important to measure the performance of the created PUF. There are various metrics, including robustness, uniqueness, and randomness. Instead of using special function operations, we apply a simple logic circuit using the challenge and PUF as a binary matrix. The simplest operation is the XOR gate operation, where the function and the inverse function are the same. To evaluate randomness, analyze the response of one PUF to multiple challenges. To evaluate uniqueness, analyze the response of multiple PUF from one challenge. In this case, the response should be different from each other. However, different responses does not mean having the inverse. It is hard to say 1100 has different information from 0011. Instead, information 0110 and 1001 may have more different information from the perspective of 1100. So we use the Hamming distance as a metric to evaluate this. The Hamming distance is the value obtained summation R XOR gate outputs between two strings and dividing the total length of the string. When two responses have different information, the Hamming distance should be close to half. When n responses are present, Hamming distance can be calculated by n squared minus n. A reliable PUF produces a histogram of Hamming distance with low variance and average close to half. Any material with an unpredictable pattern has the potential to be used as a PUF. In the semiconductor process, etching using via hole mask of an ambiguous size to reach the metal air barrel can generate an unpredictable binary key, so it is used for PUF. Next, two PUF cases were introduced in Nature Electronics and Advanced Material last year and this year. In PCP case, a broken polymer-based lamellar pattern can be stacked to increase PUF complexity. And in PUF that utilize perovskite material can sampled at both micro and macro scales. When PUF is used in security system, personal information can be protected that is difficult to protect with existing software-based security systems. Thank you for your attention.